Hello students, welcome to the session. Today's topic for the session is decimal representation from your chapter 1 real numbers, class 10th. So let's start the session. So we will see the decimal representation of for both rational numbers and irrational numbers. Irrational numbers. Okay. So first of all, we should know our basic definition of rational numbers. So rational numbers are always written as P by Q form first, where Q is your non-zero. Third, P and Q are integers. Okay, this is the form of a rational number in form of a fraction. But now here we will discuss about their decimal representation. So now additionally this rational numbers have a decimal representation as they are terminating, they have terminating decimal expansion. The rational number will have terminating decimal expansion or non-terminating and repeating decimal expansion. So we will now understand what these terms means. Terminating decimal expansion means, see, what is your terminating decimal expansion? Terminating decimal expansion means if I have an example 30 by 8. So this is my rational number. Okay. So if I divide this number 30 by 8, so I will get a number in terms of decimal. So let's do it. 24, 3. This is your 6. Okay. Now put the decimal. 7, 8, 56. This is your 45. So this can be written as 3.75. See, this was a pattern of a rational number P by Q where Q is non-zero. And if we write this rational number in terms of a decimal expansion, it is written as 3.75. And this 3.75 is your terminating decimal expansion. Why? Because it has ended. After decimal. There are only two values. 7.75. It has ended. It is terminated. Okay, it is terminated. So that's why this expansion is your terminating decimal expansion. Okay, now let's understand. This is your category of a rational number. Okay, possesses rational number possesses terminating decimal expansion. Okay. Second, rational number possesses non-terminating also. Non-terminating but repeating. Non-terminating but repeating decimal expansion also. Okay. They have a non-terminating but repeating. For example, if you have 1 by 3, this is also your rational number, but if you go on dividing, okay, so you will get 931093. That will be your always 0.333333 and so on. Always. Clear? So this is a case of your non-terminating, but after the decimal, the numbers are repeating. So this is also a category for a rational number. Okay, so rational number possesses both these terms. Okay, next is your now decimal representation. Okay, We have discussed rational number. They possesses terminating decimal expansion and non-terminating but repeating decimal expansion. What about irrational number? So irrational number possesses non-terminating. They possesses non-terminating and non-repeating. They will not follow any pattern. Okay, they will not follow any pattern. See, in terms of repeating, we can say this is also a decimal expansion 361, 361, 361. This is also a non-terminating but repeating case also. See, after some time, after three places, you are again getting your 361, 361, 361 like this. Okay, so this is also a case for rational number, but here non-terminating and non-repeating. That means after decimal, just say 1.73, 2, 1, 5, 6, 8, 9, and so on. Your digits are not repeating and it is not terminating also. So these are the cases for your irrational number in terms of decimal expansion. Okay. Now let's identify the given fraction as a rational number or not. So if we want to identify without using the division method, how we can identify whether my given decimal is the fraction is your rational or irrational? See, I have three rational number. So I want their decimal expansion, whether they are rational or not. See, now focus on their numerator. So it is your 80. So let's do the prime factorization of 80. So it will be your 2, 20, 2, 10, 2, 5, 2 to the power 4 and 5. See, so if in denominator they have a factor 2, 5 or both. Okay. So in denominator, if you have 2 as a factor, 5 as a factor or both, then this type of rational number will have terminating decimal expansion. Clear? So only 2, 5 or both. Other than 2 are not allowed. If they are there, we will say this will be not your terminating decimal expansion. They will be non-terminating. Okay. So we are categorizing only the rational number cases. Categorizing only rational number cases. Now see, it is 7 by 24. So 24 can be written as 2, 12, 2, 6, 2, 3, 3, 1. So this is your 2 to the power 3 into 3 to the power 2. Okay. So here 3 is coming. So 3 is not allowed. 3 should not be written. So this will be your non-terminating decimal expansion. We are only telling about the terminating and non-terminating. Okay, this rule is for only saying about terminating and non-terminating. Okay. Now 16 upon 125, this can be written as 5 into 5 into 5, and this will be your 16 by 5 to the power 3. So again, we have 2, 5 for both. So here 5 is present, and other than 5 there is no other element is present. Therefore this will be your terminating decimal expansion. So we have discussed about the decimal expansion, whether they are terminating or non-terminating. Okay, so that's all for today's session. I hope you understood the topic. If you have any doubt, you can contact me through my Urban Pro profile app. Till then, revise. Let's meet in the next session. Thank you.